Hello, my name is Freeborn Goodluck Otuya.
My name is Gabriel Stanley Chukwukalibia.
Welcome to Studysmart, where you learn faster and retain more.
Welcome to Studysmart, where learning meets ease.
Please like, share, subscribe, and comment. Study smarter
and not harder.
Hello everyone, welcome back to Studysmart. In today's video, we are going to be looking at power sets. In our previous video, we talked about sets, the definition of sets, and the various representation of sets. We talked about the basic operators of sets and the various types of sets, but remaining only one, which is the power set. That is what we are going to be talking about, the power set. The power set. The power set of an element is, or you can say, the set of an element, or the power set of an element is said to be all possible subsets of that element. The power set of an element is said to be all possible subsets of an element or of that element, including the empty set and the set itself. What that means is that if I have A to be equal to the set of these numbers 2, 3, let's start from here. Let's start from there. Okay, let's start from this. And we are asked to find the power set. The power set of an element is being denoted or represented by this. This is what we use in representing the power set. Where n is the number of elements in the set. N is the number of elements in the set. So now, let's find this power set of this set. We are given A to be a set of 2. This is a singleton set because it has only one element, and they are asking us to look for the power set of that element. Don't forget, a power set is the set that has all possible subsets of that element, including an empty set and itself. What that means is that if I'm asked to represent the power set or find the power set of this expression, first of all, I'm going to look for the number of elements in that set, which is n. The number of elements in this set is what? Just 1. That's the number of elements in this set, which is 1. And then because the number of elements in this set is 1, and from power sets, we know that it is the possible number of all subsets, and the empty set. That means you have to include the empty set as part of the subset and the element itself. So now I'm going to look for the power set of A. The power set of A. We are going to start from the empty set because we are going to be including the empty set first in the subset, which is the empty set. I will give a comma, and we have the set itself. 2. So this is the power set of this expression. There are some other way of finding power sets, but there are some complex examples in power set. Let's quickly take one. A to be equal to the set of 2 and 3. And then let's find the power set. Let's find the power set from this expression. We know that n here will be what? 1, 2. So the number of elements in this set is 2. The number of elements in this set is 2. Sorry. The number of elements in this set is 2. So here becomes 2. So from our formula or representation of power set, we have that P or power set of A will be equal to 2 raised to power n. And n here is what? 2. So power set of A will be equal to 2 raised to power 2, which is what? 4. Which means that the number of subsets I'm going to be having should be what? 4. Unlike this, the number of subsets I'm going to be having here is 2, because by the time I say P of A equal to 2. Now, n here is 1, so 2 raised to power 1 is 2. So I have 2 subsets in this case. So for this case, I will have up to 4 subsets. So how am I going to tackle this kind of issues? Don't forget, I will always start with an empty set. This is an empty set. And then I will take the elements singly or singularly. I'm going to take them one after the other. Then later on, I can take them in twos, because it is a possible number of all subsets, including the empty set and the set itself. Okay, so I have the empty set. I will take this one, which is 2. I'm taking them 1, 1 now. I have 3. I will take 3. And I have the set itself. I'm going to take 2 and 3. Now, if you count this thing, we have up to 4 subsets, which is 1, 2, 3, and 4. Alright? 1, 2, 3, and 4. It must satisfy the number of subsets that you've gotten, which I've gotten 9 to 4. I've gotten about 4 subsets here. What if we have, let's say, find the power set. Find the power set in this set. A equal to 2, 4, and 3. So how do we find the power set when we have about 3 elements in the set? So now, we are first of all going to write down this our formula, which is P to the power set of A to be equal to 2 raised to power n. Here our n is what? 1, 2, 3. Our n is 3. Alright? It's not this 3. Okay, let me just change this value and let me put 5 here. So our n is 1, 2, 3. The number of elements in the set is 1, 2, 3. That's the number of elements. So n is equal to 3. Now, I'm going to substitute 3 to this place. I'll have the power set of A to be equal to 2 raised to power 3. 2 raised to power 3 is 8. Which means that the number of subsets I'm going to have should be 8. The number of subsets I'm going to have should be 8. Firstly, let me start by the power set of A will now be equal to, don't forget we are starting with an empty set. That's what we are going to be starting with. An empty set, a listing out the subset. We start with an empty set. So now let's look at our empty sets. These are our empty sets. We separate by a comma. And then now from these elements in the set, don't forget I said we're going to be taking them individually. We're going to be taking the elements individually. Then from individually, we take them in twos. Then after taking them in twos, then we'll not take them in threes. Just the way they are. So now let's start. We have an empty set. And then we're going to take them individually. We're going to start from 2. And then 4. And then 5. Now we are done with taking them individually. So we'll go in twos. So So now it works this way. This and this and this, then this and this. Okay? This and this and this, then this and this. So now let's do. We are going to have this and this. That is 2 and 4. That will be 2 and 4. We have the comma. We have 2 and 5. We have 2 and 5. And then we have 2 and 5. Okay, we have 2 and 4, which is this. We have 2 and 5, which is this. The last one we have 2, that is 4 and 5. 4 and 5 and 5. So how many number of subsets are we having here? This is 1, 2, 3, 4, 5, 6, 7. So it's the remaining one, which is for taking them in twos. This is in twos. This is 1, 2. That is 2 and 4, 2 and 5, then 4 and 5, which is this. Then we are going to take them in 3. Which is 2, 4, and 3, which is the elements, the set itself. 2, 4, and 5. Alright? So that's our answer. So now if you check very well, it satisfies the number of n, the number of sets we have here, the number of subsets we have here, which is 8. So we have one, don't forget, you must start with an empty set. You must start with an empty set. You are not skipping the empty set because it is the possible number of all the subsets, including the empty set and the set itself. So you are going to start with an empty set. Then after, you are going to take all the sets individually. Then after taking all the elements, individually, if they are more than 2, you take them in twos. Then after taking them in twos, you take them in 3. After taking them in 3, just like that, take them in 4 until you arrive at the set itself. So this is what we have as our final answer. What if we are asked to look for the power set? Let's say find the power set of A equal to the set of 1, 2. Okay, let's use alphabets now. Let's use A, B, or let's see A, E, I. Oh, this one will be very good. Okay, let's just use, we've talked about, okay, let's include 4. Let's say A, B, C, and D. Let's use this. Find the power set of this element. So what we are going to be having, since we know that our power set is equal to 2 raised to power n, and the number of n here will be 1, 2, 3, and 4. So the number of n is 4. Is 4. So we are going to substitute n to this expression. This will be P as the power set of A to be equal to 2 raised to power 4. 2 raised to power 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this simply means that we are going to be having a total subset of 16. A total subset of 16. So now let's start by listing out the subsets. We are going to be starting from an empty set. Don't forget, always start with an empty set. Empty set. After starting with an empty set, we are going to list all the sets individually. So we are starting from set. The first element, A, and then we are going to enter B. We move over to C. And then D. We ended up tackling them individually. Then the next task is to take them in twos. We've taken the empty sets, which we will never avoid. It is very important. taking the empty set. First, you take it one after the other, after taking the empty set. From the beginning, you take the empty set, then you take each of the elements in the set, one after the other. Then after you are going to take them in twos. So of taking them one after the other, then we move over to taking them in twos now. So this is AB, we take AB. Then we take AC. And we take AD. So we are done with A. So let's move on to B. You cannot do BA. No, it's not possible. What you continue from is from here to this part. You cannot come back to do BA. So after dealing with A, you go back to B and you continue just like that. This is BC now. And then you take BD. Then we are done with B. So move over to C. So this will be CD. So we are done taking them in twos. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we are still left with how many? We are still left with 5. I think 5. So we've taken them in twos. So move over in taking them to. We'll be taking them in 3 now. So we've taken this, and then we'll move over and taking them to 3 elements now. So this becomes A, B, and C. A, B, and C. So this is A, B, and C. After taking A, B, and C, we take A, B, and D. We take A, B, and D. And after taking A, B, and D, we take B, C, and D. B, C, and D. So how many is left? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's check. We have AB, we have ABC, we have ABD, we have BCD, and we are going to have ACD. Okay, we have ACD. We have ACD now. And then lastly, we are going to have, okay, that's all. And then we are going to have A, B, C, and D. So if you count the number of subsets here, it should be 16, which satisfies the power set law. Alright? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is the answer to this problem. Then we are also going to look at venn diagram. A venn diagram is a diagrammatic way of representing sets. A diagrammatic way of representing sets. In venn diagram, sets are being represented in this form. Alright? Why this is the universal set. Okay? So these are the sets. Why this is the universal set. So now let's take some few examples that we'll use in representing some types of sets in this venn diagram. Now let's say represent in venn diagram. represent in Venn diagram. 1. A disjoint set. Then 2. Intersection of sets. 3. Union of sets. And then 4. Complement of sets. And then let's take lastly difference of sets. So we are going to be representing these types of sets in a Venn diagram. Alright, the first one is the disjoint set. Don't forget, a disjoint set of A and B simply means that in A and B has no elements that are common between them. For example, if I have A equal to 1 and then B equal to element 2 or set 2, set of this element. This is actually a disjoint set because in A I don't have 2 and in B I don't have 1. So they are having nothing common in them. So if I want to represent this in a Venn diagram, so this would be, since they are nothing common, they cannot join. So they will be separated in this form. So this is a disjoint set. This is a disjoint set using a Venn diagram. And then secondly, we also represent intersections of sets. Intersection of sets. That is the elements that are common in both set A and set B. If I have A to be equal to 2 and then B to be equal to 2, this means that this is an intersection of sets because it has both 2. It has 2 in both sets and 2 is common in both. I can find 2 in A and also find 2 in B. So how do I represent such statements in a Venn diagram? I have this and I have this. So this point where A and B are meeting, this point where A and B are meeting is the intersection point. The overlapping part is the intersection point. That is for intersection of sets. And then number 3, the union set. Union set. Don't forget, a union set is the combination of the elements in set A and the elements in set B. So which means that if I have this set A and I have set B, the combination of elements in set A and the elements in set B gives me the union set. So how do I represent that in a Venn diagram? So all elements in set A combined with elements in set B gives me the union set. So this is how it is being represented. And then we have the complements of sets, which is number 4. Complement of sets. So now, complement of sets is a set where all the values in the universal set is not found in A. Is not found in A. Which means that if I have a set A here, no value in the universal set set is being found in A. So it becomes a complement of that set. So how do I represent that in a Venn diagram? So this is the universal set, and this is the set itself. And no value from this universal set is found in A. So how do I represent that? I'll just come and shade this point without touching the set A. Without touching inside of this set A. This becomes our complement of set. And then lastly, which is number 5, set difference or difference of set. Difference of set. If I have two sets, A and I have another one, B. The difference of this set is the set or element that are found in set A, but are not found in set B. If element found in set A, but are not found in set B. So how do I represent this kind of set in a Venn diagram? So let's start from, let us say A minus B. A minus B, which is the set in A, but not in B. So I'll just come and shade the A part of the set, and then I'll leave the B part of the set unshaded. So what if I have B minus A? That means this set will become something like this. If I have A and I have B, this means that the elements found in B are not in A. I will only shade the B part of the set. That is the difference of the set. And that is the answer to that problem. And also note that A minus B is not equal to B minus A. And A minus an empty set is equal to A. And then an empty set minus A is equal to an empty set. So that is all. In this video, we've talked about the power sets and some representation using the type of power sets, using the type of sets in a Venn diagram. Don't forget to share your thoughts in the comment section. Also like, share and subscribe to this YouTube channel. Thank you and see you in the next video.